All right, this is the third video for section 1.1 that talks about functions, and this will cover the third and final objective in this section. So for this objective, we're going to find the domain of a function, and to find the domain, what we're really asking is what x values make the output a real number. So what x values are we allowed to have? Okay, so find the domain of each of the following functions. So for the first one, we're thinking about what x values are we allowed to plug in. Well, with a fraction, we want to think about things that will not cause us to divide by 0. So the easiest way to do this will be just to try to factor the denominator. So x plus 4, we'll leave that alone. And then for the denominator, we want to say what multiplies to get -3 and adds to get -2. So that will be -3 and +1. So this is the factored form of the denominator. We would not want to plug in x values that cause us to divide by 0. That would be undefined. So if we set each of these parts of the denominator equal to 0 and solve, this will give us the two x values that do not work for this function, the two x values that we are not allowed to plug in. So you could say not equal to, equal with a slash through it. Okay, so the domain, or the x values that we're allowed to have for this function f of x, would include all real numbers x except for -1 and +3. Let's see how I can write that. So this would be all real numbers x such that x is not equal to -1 or +3. Any x value, positive, negative, or 0, will work except for these two. Okay, check out the second one. Any x values that would not work here. Well, let's just think about what numbers we could plug in. If we plug in a positive number and square it and subtract 9, no problem. If we plug in 0 and square it and subtract 9, no problem. If we plug in a negative number and square it, that would give us a positive and then subtract 9. Again, no problem. So there's nothing here that's going to cause a problem, so this would just be all real numbers for our domain. Okay, so you could say all real numbers. Or let's see, how else could I write that? In what's called interval notation, you could say -infinity up to +infinity. That's all numbers, all real numbers. Okay, for part C here, again, we're thinking of what we're allowed to plug in. If I actually think of some values here, let's just make up a number. If I plug in, let's say 6. Three minus 12 under there. So that would be square root of -9. Well, this is a problem. You can't take the square root of a negative and get a real number. You can do it in imaginary, but not in real numbers. So 6 is a value we would not be allowed to plug in. What other values are excluded? Any larger numbers? Numbers larger than 6 would be excluded because that's going to give us a negative number under here. So what you really want to find is what's the first number that you are allowed to plug in. So to do this, I'm going to set this greater than or equal to 0 because I do not want to have a negative under the radical. Okay, so solve this. Subtract 3 on both sides. Okay, then remember the old algebra tricks here. When you multiply or divide by a negative with an inequality, you are going to reverse the inequality symbol. So it was greater than or equal to. Now it's less than or equal to. So x is less than or equal to 3/2. Okay, so you could write it like this. X is less than or equal to 3/2. Or you could write it as, let's see, from -infinity all the way up to 3/2 included. So equal to gives you the square bracket there. interval notation. Okay, so on the next slide we'll summarize the rules here. This is what to do. Alright, so the two main rules that we just looked at, if you have a fraction, in order to find the domain, what you want to do is set the denominator not equal to 0 and solve it. We're saying that we do not want that denominator to equal 0 because you can't divide by 0. Okay, for a radical, what did we do? We took what's underneath, so that's the radicand, the part underneath the radical, greater than or equal to 0. This is to make sure that we are not taking the square root of a negative number. So these are the two rules that we've seen for fractions and radicals. The one we looked at part B had neither of these, so it was all real numbers. All right, finding domain for an application problem. Problem says a rectangular garden has a perimeter of 100 feet. Express the area A of the garden as a function of the width W and find the domain. Okay, so the first thing we need to do here is write an area function that is only in terms of width. Okay, so let's just write down what we do know. I know the formula for the area of a rectangle is length times width. And the formula for the perimeter is going to be 2 times the length plus 2 times the width, and they did tell me that that's 100 feet. Okay, now I'm going to use substitution to put these together. I want this area formula only in terms of the width, so I want to replace this L with some expression in terms of W, and that will come from my perimeter equation over here. So I'm going to solve this perimeter equation first for L. Okay, so subtract 2W on both sides, and then divide everything by 2 to get L by itself. So 100 divided by 2 is 50, and then this will just be minus W. Okay, so the length is equal to 50 minus the width. I'm going to take this expression for the length, 50 minus W, and plug it in right here for length. Okay, this will give me an expression for the area. In terms of just W. Okay, so I've done the first part. Now what? Find the domain. I need to figure out what values I'm allowed to have for W. So first of all, just think about a rectangle. If you have the width of a rectangle, it can't be negative. It can't be 0 or it wouldn't be a shape. So we need our W to at least be greater than 0. Okay, now can it be anything greater than 0? Well, let's think about what numbers we could plug in right here. If I start plugging in positive numbers greater than 0, what happens if I plug in 50? Well, then this becomes 50 minus 50, and this term goes to 0, so this would be 0 times W, and that would give me an area of 0, which also doesn't make sense. So I want to make sure that this W is also less than 50, so that this factor will not go to 0. So I need my W also to be less than 50. Okay, so a couple ways to write the domain. You could say 0 is less than W, which is less than 50. Or in other words, W is between 0 and 50, not including 0 and also not including 50. And so anything greater than 0 or less than 50. Okay, so two answers to this question. Here's the area in terms of width. And then here's the domain. This is written two different ways. Okay. The next thing we're going to look at is combining functions. A couple of ways to do that. The first is the sum of two functions. So the notation is f plus g of x. and that is simply taking the two functions separately and adding them together, f of x plus g of x. Same thing for subtraction. The difference, f minus g of x, is equal to f of x minus g of x separately. Product, same thing. And quotient, so dividing, same thing. Remember here that your g of x cannot be equal to 0 because it's in the denominator of your fraction. Okay, so let's see how these work out. So for the first one, f plus g of x, I'm just going to do the first function, f of x, plus the second function, g of x. Now because this is all addition, I don't really need these parentheses. I can just combine my like terms, and I'll go ahead and put these in descending order also, just because it makes me feel better. So 4x to the third plus 2x squared. Those are not like terms. And then I can go ahead and add my 3 and my 1, so plus 4. And this is the new combined function. That is the sum of those two functions. Okay, f minus g of x. This says take the first function f, subtract from it the second function g. Here I am going to distribute this negative sign, so the parentheses do make a difference here. So this will be 2x squared plus 3. Now distributing, that's minus 4x to the third minus 1. Okay, and then combining again, put them in descending order, so negative 4x to the third plus 2x squared, and then 3 minus 1, it'll give me plus 2. So this is the combined function f minus g of x. Okay, the next one, f times g of x. So that says just multiply the two functions. Here's f of x times g of x. Okay, for this I do need to FOIL or box or whatever you do to multiply out binomials. So 2x squared times 4x to the third, that will be 8x to the fifth. Okay, so remember the rule of that when you multiply like bases, you are adding exponents. Okay, keep going, 2x squared plus 1. I'm sorry, multiply those, 2x squared times 1. So next one, 3 times 4x to the third, that's 12x to the third. And then 3 times 1, so plus 3 at the end. Okay, that one, no like terms. You can rearrange it into descending order if you feel like it. So that one's finished. Whoa, and then it skipped slides on me. Okay, sorry, all of that erased. Hopefully you have it recorded. You can go back and listen if you want. Okay, so f divided by g of x. That's just f of x in the numerator divided by g of x. You can think of each of these as having parentheses around them, so you would not try to simplify the 2 over 4 or simplify the x squared over x to the third. Okay, so this is finished. You might also specify that g of x cannot equal 0. So I'll just write that out. But you could also set that denominator not equal to 0 and solve it. So that's operations on functions. So here's just one review question at the end of our section. Determine whether the relation represents a function. So this is just a set of ordered pairs. It's definitely a relation. So take just a second to answer this question. So remember, what you're looking at here are repeated x values. So here I do see this x value 4 is repeated, which means that this is not a function. Alright, so this concludes the lecture for section 1.1 functions, and you can go ahead and listen to the lecture for section 1.2 and fill in those notes as well in the next video.